Hi, everybody. Welcome and good afternoon. I'm really excited to be giving this Learn at Lunch today about a subject I'm pretty passionate about, and that's systems and data within the parking and mobility industry. I've adapted this Learn at Lunch from a couple different presentations I've given, including a webinar for the International Parking and Mobility Institute, and I've tried to make it as UCLA specific as I can for you all. I've tried to leave plenty of time for questions at the end, but please feel free to drop them into the chat. I'll try to keep an eye on that as we move through. Just a little bit about me for those of you who don't know. I'm the assistant director for analytics here at E&T, and I've been at UCLA since 2016, where I've led a number of data-driven projects here, most notably Brew and E-Permit. I've been leading the analytics group at Commuter and Parking Services since 2017, and in March of this year, the analytics group was moved sort of centrally to support all of events and transportation. I'm very fortunate to lead a wonderful team of analysts and data scientists, Tim Benuelos, Tiana Chan, Celia Chung, and Dylan Henson, and their work has made a really huge impact here at E&T, and I'm really glad for the opportunity to show off a lot of what they've done and what they do. All right, so just first briefly, a quick agenda for today. We're going to cover some basic definitions about data, discuss some storage methods and interaction tools, and then discuss why data is important to you all, including metrics. And finally, I'm going to review some examples of some work that my team has worked on, and then also talk about the analytics team mission and what we're doing here, our values, so that you all can learn a little bit about the shared resource that we have at E&T. All right, so starting really at the very base level, data is a collection of facts. So this really could be anything at all, from the number of light bulbs we changed last month to revenue collected. We do a ton of revenue reporting, and I think that's sort of the most common data source that people hear a lot about, budgets and money. But you could also have things like swipe-ins to time clocks or power utilization, or less structured data like online customer reviews, parking citation appeals, or cases that come into our CRM system. Analysis seeks to take those facts, that information, and really make them useful. And it can take a lot of different forms. So I mentioned earlier budgeting and reconciliation, where we're trying to project information into the future or resolve what has happened against what we thought might happen, to other things like operational decision support. So trying to resolve two different alternatives or explain what's occurring out in the field. So that's what data is and what we're trying to do with analysis. So where do we keep it? Data is stored in all kinds of different places. And when I first got to E&T, we had these huge file cabinets of paper kind of all around the office. I think those have mostly kind of gone away, but paper is really the original data storage medium. Humans been using it for 4,000 years, and of course we're still using it today. But spreadsheets and systems have largely taken over the data storage task. And all systems that we use store information in databases behind the scenes. For our purposes today, it's pretty safe to say that all of these systems use relational databases as their back end. There's some nuance there that's not really important for today, but just know that every system you're using today, from Instagram on your phone to Brew and E-Permit, has a database at the back end, and that's where information is stored for those systems. A relational database organizes information into predefined relationships into one or more tables. So essentially what that means is you might have a table full of customers and a table full of parking permits, and the relationship between customers and parking permits, that's predefined in the database. So it's not something where you would have to look that up and kind of make it up on the fly. We've predefined all of that. Now, if you've done a lot of work in Excel, you've probably used something like the VLOOKUP function, where you're pulling in information from one table, from one column, and you map that into another sheet or column on a different table. Relational databases really work on kind of the same principle. Information from one table links to information on another table using unique identifiers or keys. So those keys are really the secret of jumping from one table to another. At one level up from that, we've got data warehouses. And data warehouses are systems for analysis and reporting, and these consists of tables of data from relational databases. In some cases, you might have entire copies of production systems. So we do this at UCLA. We take an entire copy of the Brew and ePermit T2 Flex database and copy that into our data warehouse on a nightly basis with some more frequent updates than that. But in other cases, you might have very small fragments of information from systems, and you store just smaller or ad hoc sets of information. So for instance, our pay station information we store in our data warehouse, we're really only grabbing one table of information there. We're not grabbing the entire system. An example of an ad hoc collection of data that we might store in a data warehouse would be something like a list of attendees at a particular event. We might want to store that and record that into our data warehouse, but that would be a static list that doesn't update. So those are kind of where we store the information, but how do we interact with it? And I think everyone here has used a front-end system to interact with data today. It's so common to say, oh, I'm going to pull a report out of the system. And every system we use has a reporting capability built into it. Some of these are customized PDFs that you can generate, or you might have dashboards. Most of them even include the ability to create a CSV file, a comma-separated values file of text that you can export that information and move it off to Excel. Excel is a really ubiquitous and powerful tool. So you've got functions like pivot tables, data manipulation functions like VLOOKUP that we were talking about earlier. There's literally hundreds of different functions that Excel understands, and they're constantly updating what Excel can do. And there's code-based tools to interact with Excel as well. VBA is a programming language that allows Excel to handle many dozens or hundreds of different use cases that nobody's ever thought of before. I've seen examples where somebody has kind of hacked Excel to the point where they can browse the internet through Excel. That's not recommended, obviously, but Excel is super powerful. And so there are important limitations with Excel, however. So for instance, Excel's technical limitation is that it can only handle 1 million rows of data. And while that's technically it can handle that, if you've ever actually tried to work with a data set that large in Excel, it really is quite difficult to actually use, and it practically doesn't work that well. So if you're working with these really large data sets, anything over 100,000 rows or more, you're going to want to use a relational database to handle that and interact with that using SQL, the structured query language. And this is a code-based tool for interacting with data. It's been around for several decades now. And this is really the primary tool for defining databases, getting information out of databases, and being able to manipulate records within a database. We have quite a few SQL ninjas in the department. I would certainly say my team has got a lot of skill there, but if you look to IT as well, Vincent, Ken, the rest of Tyler's team, a lot of SQL ninjas there as well. That does really require a lot of code-based work, however. And so for somebody like me who doesn't really write code, or at least doesn't write any good code, sort of business intelligence tools have burst onto the scene a couple decades ago. And in recent years, they've really lowered the skill level needed to interact with data in more raw forms than you would from the front end of the system. And we'll see a few examples of analysis work that the BI tools have done a little bit later on. But really, the key innovation that I see with these business intelligence tools is the ability to go to a data warehouse, do analysis and reporting work from many different systems all at once without having to write really a single line of code, being able to take that analysis and publish it so that other people that you work with can see it on a live basis without the need to kind of rerun things. It's something you can do completely without writing a single line of code, and you can publish your own reports, your own analysis. So those are BI tools. Looking more into the statistical and programming side of some of what we do in data analysis. Python and R are among the many programming languages used to do stats work. Those are kind of the two big ones. Python is a very versatile programming language. It's kind of can do a whole lot of different things, and it is very common in the stats-focused data analysis space. More recently, auto machine learning tools, so these are things like RapidMiner, are kind of a new entry into the area of analysis, and they come with some preloaded machine learning abilities and other stats algorithms. So they're not quite as far along as some of the business intelligence tools that are out there, but they allow people without a line of code to do machine learning on data sets. So that's just one other area that I think everybody should be aware is kind of on the horizon as technology gets better and better. This is definitely an area that is developing currently. All right, so we talked a lot about how we store data, and we've talked about how to interact with it, a few different tools for that. But why does it matter? So I think the core is that data and data analysis allow for fact-based decision making. I'm sure you've all had the experience of being in a room full of decision makers who bring their own experience to the table, and they believe that they know the right way to handle something or how an issue is going to unfold. And I'll tell you, they are right a lot. After all, these decision makers didn't get to be decision makers by accident, and us as humans, we're the primary species on the planet. Go humans! We really, have a lot of skill in interpreting information and coming up with ways to approach problems. But being able to say, hey, these are the actual facts of the matter, bring those facts to the table, allows for not only higher quality decisions, but also a path forward. So, if we take kind of a simple example here where, somebody says, oh, we're working too much overtime, and leadership says, well, overtime's got to be reduced. If one unit says, okay, we're going to reduce it, and the other one eliminates it, so one takes it down 5% and the other one cuts it by 100%, but has a host of customer service failures that come with that, that's obviously a bad outcome. If you take the time to measure what's happening first and say, oh, we need to get overtime to within 15% of total hours worked, units can then present choices up about what needs to be cut and how to do that. I'm the biggest analysis fan out there, but we're never going to be able to do this all the way down to one number. We care about so many different things that it's really important that we're careful to look at the whole problem and analyze it from different angles. So, some other forms of analysis include exploratory analysis, where we take a data set first and we say, okay, we're going to hand this data set to an analyst and ask them to make sense of what's in there. We might be trying to find issues that operational teams are unaware of. I want to just sort of note as a moment of caution here, it's impossible to do good analysis work without sufficient background information. If you've got minor changes in system and process, system configuration or process, that can look like a major change in the data set. And it's really critical that analysis and reporting teams have a close relationship with operations that as they conduct their analysis to make sure that they're not making mistakes. And just a quick example, before I came to UCLA, I worked at another university, and I was attending a presentation where there was a director who said events had increased more than 100% on campus over the past year. I actually happened to have been working in that office at the time of that increase, and I knew exactly what had happened. We made a process change which said that every event that got booked could only have one day, and previously you could have multiple days for an event. So that minor process change meant that it looked like there were a lot more events happening, but really it was just a system change, right? And something that didn't change the reality on the ground. It was something that was happening exclusively in the office. I always tell that story because data is really powerful. Data analysis is really powerful, but it can also misinform people if you're not properly applying it. So, data analysis is a critical basis for improvement. If we don't know where we are, we can't know if we're improving. All right, so a few more words about metrics, and then we're going to look at the UCLA administration balanced scorecard, and then move into some really mobility-focused systems and metrics. So metrics are data points that are tracked through time to track the success and assess the status of a specific process or operating unit. So essentially, we're looking at one data point over time and saying, okay, is this unit answering the phone in a timely manner? Are we responding to emails? Are we making enough money to ensure the financial health of the unit or units? Metrics don't have to be that high level, though. Tactical operational outcomes really make fantastic metrics, and they give leaders the ability to understand what's happening in operations. One thing that's really very common is that you'll sometimes see that supervisors don't have as much visibility into what's happening on the ground. And so while somebody who's on the phone all day could tell you exactly what was happening with customers that are calling in, somebody who's a director might not have as much visibility and might not know as much. And so metrics offer a window into those operations. Metrics also often measure competing and contradictory aims. So I want to point out here the UCLA average vehicle trips to campus over the last, I guess that's 30 years, right? And so in 1990, UCLA agreed with the city of LA that we would not exceed 140,000 trips per day to campus. So that's one of the key restraints that we have as a university, and it's one of the things that we have to keep an eye on as ENT, as the people who are responsible for ensuring that we're meeting this goal. If we exceed this level, we're not going to be able to build new buildings or increase enrollment. But as you all know, parking revenue is generated through vehicle trips. People don't pay for parking if they don't drive to campus. So ENT is in a bit of conflict there. And so that is just one example of the many where we track a lot of different aims and we try to combine them. If we look to UCLA administration's strategic plan, the plan really recognizes that there are trade-offs that exist all over administration. And if we look at the balanced scorecard here from the customer, business process, workforce capabilities, and financial, we see the focus areas, but it's really a balanced scorecard. So that means that you have to weigh all of these things when making a decision. We can't spend unlimited sums of money. We have constraints. And so we can't make service bad in order to save a couple dollars, but we can't spend all that money to make sure that we're answering every email within 1 minute. We see that data and metrics are really present throughout this. In order to improve in these areas, we have to track baselines, set goals, and develop action plans for those goals. So if you look at customer service improvement metrics, those could include things like time to answer phone calls or respond to emails. Sustainability metrics are something that we're going to hear a lot about, and we're going to continue to hear a lot about. Greenhouse gas emissions, tons of waste, power usage. There are dozens or maybe even hundreds of different things that are important for UCLA to track in order to meet these sustainable goals. Financial, as we're looking to kind of reduce costs and continue to recover from the pandemic, tracking all of the different things from budgets to expenditures is all very important. I just want to reemphasize this is a balanced scorecard, so we're not looking to emphasize any one of these things at the expense of all the others. And data really is important to ensuring that we are pursuing all of them. So I'm going to pivot here for a minute, and we're going to talk really about parking and mobility organizations and the different data sources that are available to us. And we'll start with short-term payment systems. So pay on entry is kind of the first major set of systems that generate data within our organization. And the way that works is customers pay when they enter the parking facility. There's a whole bunch of different names that this goes by within the industry, from pay by plate, pay by space, on-street meters, our daily parking that we sell through Brew and E-permit. That all could get lumped into kind of pay on entry. Some features of this is that it's generally less equipment to put out in the field. We don't need to put gates at every entrance and pay stations on top of that, and then also exit gates with payment mechanisms at the exit, some integration with permit systems. There's a lot of equipment associated with pay on exit things that we really don't have to do with pay on entry. It does require customers to pick the time, how long they're going to be there at the point that they come to park on campus. And so that is one kind of drawback of the pay on entry system. Some of the app-based parking systems like Park Mobile kind of resolve a little bit of this by allowing people to do things like add time to their transactions. And depending on the implementation of this, you can get a lot of really great data about your customers. If you're doing pay by plate, you have a unique license plate and you can kind of see, okay, how often is this plate showing up? Or if you're doing pay by space, you get to see, okay, how often is the space turning over? Versus something like a on-street meter that people put quarters in, you really don't know a whole lot about what the behavior is there. Pay on exit facilities, generally these are gated, as I was talking about earlier. You pull a ticket when you get in. It's great for generating data about how long everybody is there. You know exactly how many minutes people have stayed. But generally, you're not going to have a lot of information about who actually did that. But there are some integrations with other systems like LPR and permit management, which do allow you to learn more about that. And we're gonna get into a couple examples of data analysis on both of these different kinds of payment systems. Citations. So citations are another area of a huge amount of data that gets generated, certainly within our organization. We've got a fun mapping tool that not generally something you hear about parking citations, but we've got a great mapping tool built in Tableau that will show off, how we kind of can visualize where citations are happening. But you've got a lot of different systems involved with citation issuance, from enforcement handhelds, where you're going to generate what time the citation was issued, where the officer was, which officer was logged in, a lot of information there. On the citation collection and appeals processing side, right, we've written a citation. Sometimes somebody's going to want to appeal it. They'll certainly need a way to pay for it if they decide not to appeal it. So tons of systems everywhere here. Generally, you're going to get plate and officer data, and if you're linked to a motor vehicles department, you might get registered owner data as well. Permit management. So these are really huge and complicated systems which have customer info, all kinds of different permit offerings, often with e-commerce tools layered on top of that, and customer relationship management style email tools. If you've spent any time with Brew and ePermit, you know that the T2 Flex database that we use for that is really quite complicated, and it also does include things like allocation and space management tools to understand how many different permits get sold into different areas, and how do the variety of permit types get accommodated. Next, we've got occupancy. There's a huge variety of different approaches to counting space, including gated facilities, image analysis of surface lots. We've got that up at Structure 3 and a couple other places. And then pucks in the ground to detect a vehicle. We use that for some of our on-street monitoring as well. All of these systems require a lot of calibration and maintenance, so we need to, it's constantly a trade-off between whether it's better just to go visually check versus going out there and putting in a fancy system. Next, we've got license plate recognition. We use the license plate recognition basically uses AI to recognize and read plates, translate them into text. There are a few different flavors of this, from mobile, driving around from a vehicle and scanning plates as it drives by, to fixed at entrance and exits. Next, we got things like customer contact systems, so phones and our customer relationship management system, Salesforce, fleet telematics from speed mapping and safety, as well as parking locations for the fleet, so that we can do things like figure out where our motor pool should be or where our electric vehicle chargers need to lie. Transit, we've got on-time performance and route mapping, as well as customer counting. So these are some of the many systems within a parking and mobility organization. I have certainly left a bunch off, like electric vehicle charging, ride sharing, ride hailing. We are in a system-driven world, and all of these systems generate huge amounts of data every single day. So I want to get into one specific use case that we recently encountered, and look at our pay by plate, or pay on entry parking system. So at each of our T2 digital pay stations, there's 46 of them throughout campus. We were faced with an issue due to the parking occupancy tax, where we needed to analyze those rates to see if they still made sense in the wake of COVID, and change them so that we could pay the city of LA the tax that was there. Now, these rates are really complicated, and philosophically, we charge for parking based on demand. So the more demand there is for a particular parking area, the more expensive it should be. The most obvious example of this is at the law school. The daily rate is, I think, about $8 or $9 more per day than the standard $14 daily visitor rate. Now, we didn't have a great way of comparing, okay, which structure has which rates and all that. The documentation that's out there is really out there to be digested by customers who are looking at a location. And so what we found when we looked at the data was that 1 hour of parking could cost either $1, $2, or $3. This is just one example of one rate, depending on where you were parking and what time of day. So when we're looking at, okay, do these rates still make sense? The first place I want to show you is this is a basic Excel pivot table of a month of transactions. And so what you've got across the top here, you've got $1 transactions. And as you can see, there are only 8 of them in a month. So probably that's not a rate we need to keep. $2 transactions, which has about 1,200, and then $3 transactions with significantly more. Now, this pivot table itself is a little bit hard to digest. There's a lot of different locations here, and trying to see, okay, where is the bigger number versus the smaller is kind of difficult. Excel, fortunately, has a pretty cool function called pivot charts, which allows us to chart this information out. And so you can see something like, oh, hey, the $3 are in gray, and our structure with the biggest number of transactions is also the most expensive. That's exactly what we're designing for. Looks like we're good there. But then we've got other areas like structure 2, where we have maybe twice as many $3 transactions as $2 transactions. Moving on from here, we need to kind of tease this out a little bit more and see by time of day, where are these transactions occurring? Now, Excel has the ability to do some of this, but as I mentioned earlier, we're already at the kind of limits of what's easy within Excel. And so I took the same data set and I moved it over to Tableau. And what you've got here are the $2 and $3 transactions. So the $2 transactions are in blue and the $3 are in orange. So remember, our rate philosophy here is that where we have more transactions, that should be more expensive. And you've got days of the week across the top. And so what you see here is Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, this looks pretty good. We've got our biggest circles happening in the area where things are orange. Wonderful. But we can also see that there's some pretty big circles that are happening in the $2 area, the blue. And so this is just an example of how Tableau and data visualization here gives us the ability to look at a lot of information very quickly. I'm going to show you just a quick look at this video pages through the entirety of campus, and don't need to discuss it, but it gives you the ability to really just look at, okay, well, where are the trends? You can see that each different structure has slightly different behavior, different rates, and you can, within Tableau, you can stop on any of these and really dive in and get into the details here. Really just showing you one of the abilities of the tool. All right, so next up, we've got a pay on exit data analysis example. And what we ran into in Medical Plaza is that we have a grace period at the beginning of every parking transaction within the Medical Plaza. So if you drive into a gated facility, you'll find this is really common. You drive in, and if you leave right away, it's just free. Well, we got a request from Santa Monica Hospital. They had some nurses that needed to come to Westwood in order to do a quick COVID test before they could begin a shift. And so they asked us to extend our grace period from what it was to 40 minutes. Now, this happens in all kinds of pay on exit facilities, and it recently actually happened at my my child's preschool. There were a bunch of parents parking in the red. The facility changed the grace period from 20 minutes to 40 minutes, and now all the parents park in the gated facility because it's free, and they stopped parking in the red. So we got this request to change how long the grace period was, and so we needed to find out how much is that going to cost. If we used to charge people, a rate after 20 minutes, we need to find out how many of those people are we going to be letting off the hook if we change the rate structure. And so what my team took a look at, and Tim led this section of the analysis, was, okay, how many transactions do we have happening from 30 minutes to 1400 minutes? And what you can see here is that from January 1st, 2021, you have more than 3,000 transactions happening in that 30-minute window, and it actually climbs up significantly every minute that goes by. So if we were to extend the grace period, that would really cost us quite a bit of money as an organization. But there's something a little bit funny going on with this graph, and I'm sure you guys all have sort of seen a normal distribution where you would expect that this graph would just tail off into infinity as fewer and fewer people are staying longer and longer. But what's going on with these two little bumps here? And what we know from background information is that there are large numbers of employees who park in the medical plaza despite the fact that they shouldn't. And so when we went to go quantify how long or how many transactions, what the impact of these two bumps is Tim converted this from total transactions to number of minutes that were purchased. And so those two tiny bumps that were pretty small on the original slide look like much more significant parking demand generators when we convert it from number of transactions to number of minutes that they stayed. Diving a little bit deeper, Tim took a look at, okay, what are the days of the week that this is happening on? And you see on Sunday, oh, hey, this window of about 8 hours almost goes away entirely, but the 12-hour window stays there. And you see Monday through Friday, the 8-hour windows are there. And then on Saturday, again, it's gone. So, we can draw a lot of inferences from this data. I can't tell you for sure that this is generated by employees because we don't have any unique identifiers on these transactions to tie them back to people. And remember, this is to the medical plaza. So even if we did have individual identifiers, we wouldn't really want to keep that information. I don't want to know who's going to the medical plaza a lot. There's a lot of really sensitive stuff that happens there, and it's not really our business to track individuals. But this data does give us a powerful insight into what's probably happening, and we're able to work with our partners over at the medical center to identify this as a potential driver of customer dissatisfaction at the medical center with the amount of parking that's available. As I mentioned earlier, we have this really exciting map that lets you map all the citations that happen on campus. Again, there I'm being excited about parking citations, not a super exciting category, but here we've got all the citations that get issued, and we've got this fully interactive map that lets you click around and look at it. So you can look at things like, hey, I want to see everything that's happened, looking back for several months, and I can see, okay, Mondays and Tuesdays are more popular than Saturdays and Sundays. We can see the time of day. And this is just a really neat tool that we've been able to provide to our enforcement area. As you can see here, if we select down to, hey, I just want to see Tuesdays and I just want to see structure 7. Okay, now we can see, all right, so structure 7, generally speaking, we're doing more enforcement, we're getting more citations in the morning, a lot less in the afternoon. Okay, so just a quick look at this. As I mentioned earlier, we've got Bruni permit, we've got huge volumes of customer data here. We might want to look at sales trends, notices, oversell management, all kinds of things are possible in the citation management system. Occupancy. There are tons of different ways to count parking occupancy. We at UCLA rely most heavily on manual counts, where we have students go out there and count the number of available and full spaces. It's really critical to space planning efforts, but there are a lot of different ways to approach this. All of these other approaches, from loops to image analysis, gates, and license plate recognition, we've tried at UCLA, and they are very, very difficult to get accurate counts. And we've found that those manual counts really get us to the safest place from a occupancy perspective. LPR, this is another big one. This is how we're able to have online sales. We might find images, plate numbers, officers, which rule they picked while they were driving around. And we might do things like do notices off to the police department. It's called shadow enforcement. If we've got a suspected stolen vehicle, we might send a notice to PD without the officer ever knowing. We could count the number of plates scanned and track occupancy and track vehicles to see if, for instance, a shared permit violation is out there where two different vehicles are using the same permit at the same time. So as I mentioned earlier, that's kind of concludes our whirlwind tour of data available within a parking and mobility organization. But I did want to just take a moment to highlight kind of what our analytics team, our ENT analytics team values are. And here you kind of see them. First and foremost, data is cool. We are believers in data, and we think it's got a lot of potential, and we want to spread that word. Yeah, I'll let you kind of read all these. We're working to get these up on the ENT intranet, but I want to kind of emphasize a couple different things here. Numbers 2 and 3 were collaborative and client focused. So you all have, I believe, data within your organizations, and you all have a need for data and data analysis. And we're here to collaborate with you on that. So if you have an idea out there, we'd love to hear from you. And then the other one that I really want to emphasize is that we're respectful, empathetic, and celebrate diversity. We really value the diverse perspectives and each individual's contribution to the whole here at ENT. And so if you have a need and you have a perspective, we certainly want to hear from you, and we are here to collaborate with you to find solutions to whatever issues may be out there within your areas. I said I would leave a lot of time for questions, and I don't think I quite met that goal. We've got 14 minutes left, which is some time, so I will go ahead and hit the pause button. And if you don't feel comfortable asking the large group, please feel free to email me, and we can get working. Anybody have any? I said I'd keep an eye on the chat, but I don't see any. Tirza?
I have a question.
Yes, Sulema.
How do we set up a consultation with you guys? Is there a form now, or is it just scheduling a meeting with Dylan or Tim?
No form. We're depending on what you're trying to get done. I think, the easiest thing to start with is just email or Teams message to me, and we can get working from there. You can talk to anybody else on my team too, Celia, Tiana as well.
No questions in the chat, Chris. But yeah, everyone, don't be shy. Feel free to just unmute yourself or raise your hand, and we can answer any questions you might have.
Hi, Clinton.
Hey, Chris, what's up?
Oh, just drinking some water. I was talking for 45 straight minutes and the throat got a little dry.
I see. Well, I think you did a very nice job. Thank you for inviting us all to learn a little bit more about the basics of data analytics. Look forward to seeing more learns at lunches on some specific topics moving forward. So again, thank you for taking the time to share with us. Quick, I think this is probably a softball question, but we'll see.
The scariest kind.
I love learning about quote unquote parking and mobility data analytics because I'm, as everyone knows, director of fleet and transit, so a little often a different world a lot of times, but certainly see a lot of crossovers, potential carryovers, and thinking about the potential for really consolidating and combining our data analytics resources for events and transportation to include more of the fleet and transit issues coming up. So a couple things that come to mind are kind of helping us optimize where we would like to focus our expansion of brewing car shared use motor pool. I think about some thorny questions about where we should be locating electric vehicle chargers, both for permit programs and for fleet. And those things get really complicated because we need to bring in not just basic information about, oh, a customer in that part of campus uses a vehicle this much, but how intensively do they use it? How could we improve the utilization of vehicles overall? You know, how much power do we even have to charge vehicles? All that kind of stuff. So I'm just curious if you have some thoughts about the ways that fleet and transit can help your team learn more about some of our thorny problems moving forward.
Yeah, so I think first off, appreciate the question and thinking a lot about what's looking back to our values, right? We want to make sure that we're learning about everything that happens within E&T, fleet and transit included, in order to make good use of the data that's available. And your unit has invested very heavily in fleet telematics and passenger counting systems that generate data constantly. And that is, I don't want to say their only purpose, but a significant part of their utility. And so how do we make the best use of that? Well, I think first it's understanding what the known challenges are, right? We have a bucket of things that we know are problems today or known opportunities today. And then we have a bucket of known unknowns, right? And I'm sorry for the Don Rumsfeld here, for those of you old enough to remember this, but we have a bucket of things where we know there are issues out there, but we don't know how to quantify them or we don't know how to tackle them. And I think that learning a lot from you all about what those are is a really critical step in making sure that we're making the best use of data. So back to our medical plaza employee parking example, right? Without the background information from the medical parking folks, those two little blips on the graph, maybe we just move on, right? We never take the opportunity to say, oh, hey, we know this is happening, but now we finally have an opportunity to quantify it, and we're able to deliver that. And then thirdly, right, moving back into that area of unknown unknowns, right, getting the information that we can to say, okay, we know enough about how your operation works, and we have the data sets so we can begin to explain what's happening out there without a question first, with data first. I think those are really important, but it all starts with learning as much as we can about how your operation works. And a few different approaches we've taken in the past, ride-alongs with enforcement, for example, spending time with customer service agents. These are parking specific examples, but there's no reason we can't apply this to fleet and transit. Riding around on Bruin bus for a day, I think would be a great use of time.
Yeah, and I love the example you're giving about, sort of learning from the folks in boots on the ground. You can't really learn from the boots themselves. You have to learn from the people that are wearing the boots. But I think there's opportunities too for some of the teams within Fleet and Transit to sort of maybe just have 45-minute wrap session where we're like, hey, what kind of problems are you facing? What things do you not know that you wish you knew? And we can, just get more familiar. So that could be the same for any unit. And I'm sure there's some units that, haven't really even explored, the potential for more refined data analytics. So anyway, thank you for the little short conversation there.
Any other questions from anyone in our audience? Again, feel free to raise your hand or just unmute yourself and ask.
I'd be curious. I'm sorry. I guess I like to hear myself talk. I mean, if people don't have questions for Chris, are there some known unknowns? Are there things that, I don't think anybody should be scared to just speak up and say, hey, I could see how this could really apply to my problem. I would think that there are a few people on this list who might have some ideas.
If I can make a suggestion just to get maybe the mind stirring. I was in a meeting this morning where we were talking about staffing for basketball games and how we wish we had a better understanding of how many people to expect on campus during basketball games to know how to staff accordingly. And we don't really have that yet. So, maybe that's something that Chris and his team can help with at some point in the future. So things like that, right? Known unknowns. We have a thank you in the chat from Robin. She said, thanks, Chris. Really interesting and informative.
So router bus, that makes me think about that too. How are there some opportunities even for some very, we don't need to go into really deep modeling, but gosh, we've got data from the last 5 years of football games. For some people, especially those who might like playing fantasy football and all that kind of stuff, it might be an interesting little game to see, like, all right, how good were the Bruins this year and how many people came to games and, who were they playing? And, were there more people coming for router bus, a game where we were playing USC and, what about the times of the year? So anyway, it would help us be able to plan better for how many buses we needed.
This is a really interesting one. So, Dylan and Celia did a really deep dive on parking revenue for basketball games. So we had a major process change where we used to have attendants at the gate taking cash. Now everybody has to pay either online through Park Mobile, Bruin e-permit, or at the pay station. And so not having those attendants physically in the field was a major change. There was a perception that there was a significant revenue loss. And so they took that effort to quantify that. But I think what you guys are proposing is, okay, how crowded is this game going to be? And I think that that certainly should be within our ability to at least take a swing at. I think, again, back to humans being really good at intuiting things. You could say, hey, well, here's a preseason exhibition against, I don't know, some college nobody's heard of, right? Probably nobody's going to
Norfolk State.
Norfolk State, perfect. But there are some, we could probably go get some data on that and say, okay, well, are they a ranked opponent? Are they in division? Are they favored, right? What's the point spread? What's UCLA's record? What's the opponent's record, right? All those things, you put all that together, and I think with some pretty high likelihood, we'd be able to start looking at what attendance looks like. And so the Router bus is an interesting one because you're driving all the way to Pasadena and you need to staff well in advance, right? So yeah, okay, we'll
I think
Tim,
Hilda
could
has
I-
a question. She
Tim,
raised her
could I
hand.
ask you to write that down? Tim and Wallace, you still here? I saw you earlier. I don't think you
I see
did.
Tiana's here. I don't think Tim
Okay,
is, but Tiana's
Tiana,
here.
could you write that one down, please? I'll
And
take
then
that as
Hilda,
a-
I think you had a
Hilda.
question.
I do have a question. So Chris, as more and more data has become available to us, privacy seems to come up more and more, right, as an issue. So what issues have you seen come up regarding privacy with the data that we have access to? And how does your team go about protecting that individual privacy?
Yeah, so I think this is a really critically important issue, and it's related with security. And so privacy first is ensuring that we're not doing things that expose personal information. And so in order to make sure we do that, we take a review of all of our systems before they can even be implemented within UCLA. They have to be reviewed by the Office of Information Security and the Chief Privacy Officer. When new different data collection methods become available that have personal information, again, we have to do things like come up with a policy. So if you look at our license plate read retention policy for LPR, that's something that specifically addresses privacy. I think, more broadly and just zooming out, we are stewards of a lot of really valuable information, and we have to be trustworthy. And so that means thinking through, would a reasonable person expect that we're doing what we're doing? And if at any point what we were doing became the subject of a front page story in the Daily Bruin, would I feel good explaining that to all of you folks? And so some of the things that we do to ensure that we're staying on the right side of that, open dialogue at every stage. I'll call back to an example with some of the work we did during COVID. We were really interested in who was on campus, and we needed to know who was on campus so that we could do things like get them an opportunity to get a vaccine and ensure compliance with some health and safety measures. And as we were looking at the data sources that became available, we reviewed every one of those with the Chief Privacy Officer on campus, Kent Wada. And eventually we got to a point where, we were brainstorming what data sources are out there. And one of the ones that was under consideration was access to the Wi-Fi network, if you had signed into that or not. And through a discussion with him, we came to the conclusion that actually this is not an okay thing for us to be doing, because it doesn't accurately reflect who's here necessarily. You could leave your smartwatch on your desk at the end of the day or something. And it's not good enough to fully meet the campus needs. So there was a balancing test there. So I know that there were a lot of different answers there, but it's definitely something I take very seriously, and something that we as a unit are really careful about anytime we're analyzing any data that's tied to an individual.
Great, got it. Thank you, Chris.
Thank you, Hilda, for the question. We are at time now, so I think it's a good opportunity for us to wrap up this presentation. Chris, thank you so much for being here. Great presentation, great information. Chris's email is on the screen, so if anyone has any questions or would like to just kind of connect with Chris to do some sort of data dive, get into the known unknowns in their area, please reach out to him or his team. This recording will go up on the intranet and some of our other resource pages in case anyone wants to review it. And then just as a reminder, we want to continue to do these Learn at Lunches. So if you and your unit would like to do a Learn at Lunch about something, it can be something very in-depth like data, or it can be something more specific like a simple process you do that's really crucial to our business. So please reach out to me if you would like to participate in one of our next Learn at Lunches. And otherwise, thank you so much for being here. And I hope everyone has a great day. And thank you again, Chris. Great job.
Thanks, everybody.